So today the ds-incubator is about tar-q, which is the function in the package in charge of defining the rules that make a target out of date, which then the function tar-make will use that kind of knowledge to decide if a target should run or should be skipped. So that is in response to quite a bit of interest that we have seen here in these meetings, like trying to understand what exactly is happening and to try understand a bit more how to predict if tar-make will actually compute something or will skip it. So on the one hand, we hopefully by the end of this meeting we will understand how it works and we will be more able to predict that behavior, but also we will learn how to tweak the default behavior, because there is a bunch of options that we can set to change that behavior in a way that may match our own needs better. So I'm going to jump here to the one RStudio Cloud instance. I'm working from RStudio Cloud because I recently messed up my computer and everything is not working fine. So that was a great solution to getting a running environment quickly. So I'm using a very, so let me start by restarting my session. Can you confirm thumbs up if you see something that looks like RStudio? Yeah, cool. So I'm going to expand this. So as usual, we are going to start with library targets. And I should also say two things. First, to ask for a timekeeper. CJ, can you kick me out at 25 past? Thank you. And then requirements. So this is the third or fourth edition of this series. And the requirements, every session so far has been kind of self-contained, and I think that this one is too. And I'm going to explain briefly, what basically the basics in case you didn't join previous meetups. But we're going to move fast. I'm not going to be talking about the basics. So the basics are covered in previous meetups. So I'm hoping that even if you didn't attend other meetups, this one should be more or less meaningful. But for a better picture, you should probably go back to at least to the meetup about the basics of targets. So once we load the package, we can use all of its functions, including the function tar-edit, which will open the file _targets.r, which defines the pipeline. And we have covered in the basics section, in the basics meetup, what is the structure of the file. So I'm going to kind of talk through what I read here in the file as a way to kind of refresh our brains. Usually it has a few sections. So the very first section is just a call to library targets, because this file needs access to functions that exist in the package targets. Then the section after that is one where we source any files that might contain functions that we need to use in the target pipeline. Then there is a section where we define options at the global level for all of the targets. Here I do not have, for example, a call to options, so the plain base R function options, which you could, if you need it, then you would call it here too, at the level where we define things globally. And then we have a list of targets, a list of calls to tar_target. Each of these is our targets, and these are pipeline. So like a collection of targets make a pipeline, and this pipeline has only very simple steps, just 3 steps. The first one, we create a target that actually contains the path to a file that lives in the data folder. So let's have a quick look at that file now. There we go. Expand this a little bit. Here, this is the file that the first target is going to be reading. Then we have a second target that I called raw. Basically, it is a data frame that results from reading with a custom function read that we can go and see what it looks like. So I'm going to do control dot to open the go to file thingy, and I'm going to do read. Now hit enter to jump to that function. Here it is. This is just a call to read _CSV, and I'm using the argument call types to silence the messages that we get for the column specifications of a data frame when we read it with read_CSV. That function comes from the reader package, which is part of the tidyverse. That's why I did here in the options section for all targets, I'm using the package tidyverse. The third target here defines a new target called data, and it is the result of passing the data frame that we read in the previous step and applying the function clean. So if we do clean, this is what the function looks like. It's like a toy example, very simple, just takes the data set that is input and performs a mutation, adding a column and replacing an ace, or replacing an ace in an existing column. So there is not a lot to think about the complexity of the pipeline, because the focus of this meetup is not the importance of the analysis. It is instead how we understand what's going to happen with the targets. When are they updated or when are they out of date? Okay, that was the overview. So with targets, you might remember that we have a function called tar outdated. So if I call that function, the output that I get will tell me if any of the target is out of date, and therefore if it needs to be recomputed. So for example, right now the output is character 0, meaning that there is no target that is out of date, which means that if I run the function tar make, what I expect is all targets to be skipped. So nothing will actually be recomputed because the targets are out of date. So let's have a quick look at the documentation of the function here to tarqueue. So that is the source of the information that I use to learn about this idea of target queues. So we're going to be covering as much as we can of this help file. The arguments that we're going to be covering are all of this, if we have the time, and they are explained in the arguments section, and also there is a little details section. Before we even get to the arguments, there is three aspects or three criteria that targets will look for to decide if targets need to be run or not. So to begin with, the very first thing that targets do is to see if there's any metadata associated to the pipeline. If there is no metadata, it's going to be all targets will rerun, and that makes sense, right? So if I have a quick look inside the folder targets, you will see two folders, one called meta, and there we see a file called meta again, and it looks like that. So basically here in this folder targets is where target is storing metadata. So if we destroy that metadata, actually there is a function called tar destroy. That folder, boom, is gone, and now targets has no metadata. So if we run tar outdated, we should get the output that every target is out of date, meaning that tar make could recompute them all, right? So with that, we will, as you can see, it says that for every target, path, data, and pipe and row, they all run, right? Because they had to be recomputed. So if we do it once again, they will be skipped because they have already, there is some metadata for them. So that is the meaning of this first item here. So if we have no metadata, makes sense, targets will go and recompute everything. So the second point is if there is an error. I mean, I didn't figure out a good way to kind of show an example that is kind of meaningful. Basically, what it means is if I break this function, say that I go to the clean function and I break it, stop with this is with an error. I mean, you would expect, right, that target will continue to try run that target even if it didn't change because it's broken and it's giving you the opportunity to fix it. So if I do outdated, I will see that now the target that depends on that function, the target is called data and the function is clean, the function that is broken now is clean, you expect that that target will be out of date. So now if I do tar make, it will try to run that target and it will fail. It will throw an error. But even when I already run, the tar make, if I run it again, it will still try again, right? Because last time there was an error. So that's what this bullet means, right? So as long as there is an error, target will continue to try rerun that particular target. So let's undo this. So if I, undo that, now tar outdated should say it's all good to go, right? And therefore tar make will skip all targets. No, actually, it's running the data because last time it was broken. So now it has recomputed it, has stored it again. So if I now run tar make, there you go. Now it's all skipped. So let's move on to another way. And this one, I do not have an example for it. Basically, it's saying that if the output of the target is, say, a vector of characters, and then the class for some reason changed to, is a data frame instead of just a vector, then targets will try to recompute it as well. But I didn't come up with a good example, so I guess, and I think it kind of quite intuitive. If the class of the thing that the output produces changed, it makes sense that it needs to be recomputed. That target is out of date. Then there is this other item here that talks about, now is the first time you're going to be using the function that this help file describes. It is the function tarq, and you will see at the top that tarq includes a bunch of arguments. So the first argument is mode, so let's talk about that one. When you see that one argument takes many options, usually the default internally usually is set so that the first one is the default. It would be mean for a developer to choose this different default. So the default of this argument is thorough. So that is the behavior that we are kind of already intuitively familiar with. But now let's tweak them a little bit to see what happens. So first of all, where do we call that function? Okay, the q is just an argument that you can use either inside the call to tar option set, so you set the q for all targets in one go, or you can also do it in any of the targets individually, right? So if you see, there is also a q argument in each of these calls to tar underscore target. So you can define a queue for a particular target, or you can define a queue for the entire pipeline, right? That's the freedom that you have now with these two layers of control. So let's for now start at the global level. So we know to begin with that our target pipeline is updated, right? So let me clean this with Ctrl L. Run tar outdated, and what I expect is character 0, because all my targets have already run, nothing has changed. So as long as I keep calling tar outdated, I should always get character 0. But what happens if we play with that argument there? So if we say q equals to tar q, and we give it the mode, not the default, but a different one, let's say always. If I consider that targets are always out of date, then what would you expect to happen if I now run tar outdated? Consider that I haven't changed any code anywhere, right? I'm just telling targets to interpret the how targets are updated or not in a different way, but I haven't touched anything in the pipeline. So if I now run this function, you can see that targets thinks that everything is out of date. So basically, this is kind of completely changing the behavior in which target interprets things, and everything is going to be rerun over and over again if I run tar make. So before, all targets were kept because all targets were up to date. But now, through this argument, I have told targets to think, no, they are all out of date, and I want you to rerun them all the time. And we can do the opposite as well with the mode never. So once that some things are out of, actually, let me for a moment, before I show you this, let's go back to the default. One way to go to the default is to just remove that. So now everything is up to date, okay? So let me clean this with Control L. So let's go to a function and do something that we kind of know that will make the target out of date, which is, for example, to change, this function call. Let's add, I don't know, hello. So the source code of this function has changed, and targets is noticing it, because one of the criteria that we're going to get to that later is to basically read the text inside the body of a function, remove the formatting things and remove the spaces, and then see if the string remains the same or not. So now it's not the same because I have added the string hello, meaning that, if I run now tar outdated, I would expect the target data to be out of date, right? Because the source code of the function clean has changed. But if I do this, if I tell target, hey, never look at anything, just, so what it will think is that it will behave as if nothing had changed in clean. So we saw before the always, right, where even if something didn't change, then everything would be considered out of date. And now this is the other extreme, where with never we say, hey, whatever I do, forget about that, consider that every aspect is up to date. So with that, we covered that mode argument. And we are ready to, let me see if we did recover. Yeah, everything's good now. So let's see what else we can learn. So this other argument called command, where does it come from? Okay, so the argument command, if you look at the help file of targets, let's have a quick look at that with F1. I jump to the help file, scroll down a little bit, and you see that the second argument is called command. So this is command, right? So you can write it explicitly or match it by position, right? But there it is. The second argument, the expression that we pass to each step in the pipeline, is called a command, right? So with this argument to tarq, what we are saying is that the command, this expression, if a change there should trigger should tell targets to consider that command or that target in particular out of date. So if I say null here, the default behavior, so to go back to the default behavior, let me remove this for a second. So this could be the default behavior, and what I have just done is I have changed not the function read itself, I just changed the command inside the pipeline that calls that function. So what would happen here? Okay, let's have a look. So if I run tar outdated, by default, target would think that that particular target is out of date, and any dependency of it is out of date too. So that's why it considers the two out of date here. I can change that if I say, I'm not sure, I think I can do it here too. Let me reformat this a little differently for comfort. So I'm gonna say command, and the default is true, right? So if I say false, we expect the opposite behavior. So let's do command false and run tar outdated. So now what we get is that a target changed its behavior, and now a change in the command that defines the target does no longer trigger it couldn't trigger a tar make, right? So if I do tar make, everything will be skipped, right? Because now target thinks that they are updated, right? And the same thing I could do, remember, actually this command here is wrong. So remember that this command, I could also call it inside the target here, right? It's the same thing, except that now it's going to be looking just into that particular target as opposed to the whole target. Of course, if I move this from here to here, it's a totally different story, right? Why? Because this is the target that is being modified, which command is modified, and this is the target that is ignoring the command. meaning that with this way of expressing the queue, this command row will be out of date, right? So let's confirm that, and there you go. And it's not only row, but also data, because data then depends on row. And then, we have this chain of dependencies that are being traced by targets. Similarly, we have these other two arguments I would like to cover. I'm not sure if I want to do the two, but maybe at least depend, I think I can cover that one. So depend is this idea that each target depends on other targets. So what happens if I change an upstream target, right? So now let's go back to the situation we had before. This is it. So this is the default. Let's run tar outdated. Now everything is up to date. Let's clean with Ctrl L. And let's say that I want to change this target at the level of the function. So I go to the function and I add here hello. What I expect is, read now changed, therefore row is out of date. And because data depends on row, then both targets are out of date, right? So let's run tar outdated. And we confirm, right? This target didn't change. It does not depend on row. It's the opposite, right? Row depends on path, but not path on row. So because I changed something here, these two targets are out of date. But I could change that if I say depend equals false, right? So now I'm saying that the computation of data does not depend on anything, right, basically. So if I run tar outdated, now you can see that the only thing that is out of date is the target row and not the target data, which we know depends on it, right? I'm not still very sure in which cases we will want to, modify the behavior like this, but I'm sure that once we get a bit more practice with targets, we will find use cases for this. I have a minute to cover a bit less than that, to cover the other argument. Maybe I'm not going to do a lot of justice to it. Basically, in the same way that we can define queues for a lot of things, we can also define queues for when the type or the format of the file that is stored inside targets. So these files here, called inside the folder objects, these files default to be saved as an RDS file. But there is other formats that are supported. For example, the QS format. I'm not going to show it here, but I think that with having seen me play with the other arguments, I think you can figure that one out as well. And also I don't think it's super important because it could be rare that we would ask targets to save the files in a different way. It's very useful, I think, but maybe not the thing that you would do the first day that you use targets. So with that, thanks CJ, I'm already at the limit. I would like to run a little round of voices to see if there is some questions or comments that you would like to make. I have CJ first.
No, nothing to say. It's interesting that he offers these options of different ways of testing targets. It's kind of cool, but I have to really think about how that would come out in practice.
Perfect. Totally encourage. I mean, you CJ were one of the persons who are more interested in learning about these queues, and I thank you for that. It's pretty well documented. It's not a lot of documentation to read. So I haven't covered this section. So maybe if you want to read this, couple of paragraphs, you will have the full picture of what's going on here. Constanza?
No, not really questions. I'm just maybe I missed it. Why would you use that you never want anything to throw or to make it outdated? I mean, this never option is confusing me why this is for.
Yeah, I don't have right now like a use case because I haven't used it much myself other than for teaching purposes. So yeah, I kind of struggle with bringing this down to like everyday life. I'm pretty sure we will find scenarios, but I don't have anything unfortunately to share. Maybe if we have Will in the closing meeting, we can ask him, what uses people have found for this. Jakob?
Also not really
questions as of now, but I mean, it starts to all make a bit more sense and like be a clearer picture. So yeah, thanks for that. Yeah.
Thanks. Yeah, I think even if we don't find a use case for these things, like opening the magic box and understanding how the tricks work, I think is useful. Yeah. Monica?
Yeah, I also don't really have anything to add.
Thank you.
Nice, but
Alex?
I'll just chime in that one use case that I had for having the never
Perfect.
was when I was pulling data from a database. I set that target to never rebuild, so that I wouldn't have to go back and actually pull from the database every time. It was very useful when I was like just building my pipeline, and then I could run it quickly, and then once I had that correct, I switched it over to actually rebuilding every now and then.
Nice. And I also like, the finer grained control that we have at the level of each target, because, maybe as Alex suggests, sometimes, you want to experiment quickly with something, and you don't want kind of to consider what's happening somewhere else. So great. Okay, thanks a lot. With this, we can kind of wrap up here. Any exiting comment before we go? No?
Mr. Monica, didn't you? No, sorry.
Okay, and for once, we finished 1 minute before the half hour. Thank you very much. See you next time.